The Great Pyramid of Egypt had a height of 481 feet and a square base of 576 feet by 576 feet. We want to compute its original volume in cubic feet. So the first thing that we can recognize is that we can make slabs inside of this pyramid that are not circular but are more rectangular in nature. So that's just one of our slabs. And what we can do is we can integrate our function with respect to height, right? Because we're given that the height is 481 feet, and we're given that the base is square and that each of the sides are 576 feet. So we want to figure out what the original volume is. So how do we do it? How do we figure out what the volume of this slice up here is? Well, in general, the volume is the area or the surface area of the base times the height. So what we can do is we can say that the thickness of this thing is dy, right? So we're going to be integrating along the vertical axis or the y-axis. And we're going from 0 to 481. And now all we need to do is figure out what the surface area of this slice is going to be. So we can see that as height changes, so does the length and the width of the slice. So what we need to do is we need to use similar triangles to establish a relationship between the length and the width. Now we know for sure that the length and the width are going to be the same because we're told that the base is square and that square relationship is going to apply no matter where we are. So this is going to be length times the thickness. That's going to be our volume. Now we need to figure out what L is in terms of y. And to do that, we can use similar triangles. So what we can look at is this triangle right here, this purple triangle, and then we can also look at this orange guy right here. Okay, so let's say that the orange guy is at, for instance, a height of y, right? We're not really sure what the height is, and that the base is L. Okay, then looking at the purple triangle, we're told that the height is 481 feet and that the base is 756. So comparing the sides, setting up a proportion, we have that L is to y as 756 is to 481. And if we multiply both sides by y, we get that L in terms of y is just 756 over 481 times y. All right. So therefore, if we plug this back into, we plug L into L squared right here, we get this. We get 756 over 481 squared times y squared dy. And at this point, we can pull out the constant and just integrate this thing. So let's go ahead and do that. We have 756 over 481 squared. We're integrating from 0 to 481 of y squared dy. And this is pretty easy to integrate. This is just going to give us y to the third over 3 from 0 to 481. And once we apply the fundamental theorem of calculus and put this all in Desmos, we get about 91,636,272 feet cubed. So that is our answer there.